Hi. In this video, we would like to introduce Elasticsearch performance enhancements made in Huawei Cloud's Cloud Search service. Elasticsearch clusters are commonly used for data search and analytics. However, as data volumes keep growing, queries increase in complexity. Organizations face significant challenges in maintaining fast search performance, reliable data storage, and cost-effective scalability. Built on open-source Elasticsearch, CSS offers an enhanced enterprise search solution to help you address these challenges. Elasticsearch enhancements include enhanced operations and enhanced kernel. With enhanced operations, Elasticsearch clusters now use smarter monitoring, alerting, and disaster recovery mechanisms, enabling simplified cluster management and high service availability. With an enhanced kernel, query processing algorithms and data storage structures are optimized for Elasticsearch clusters. This enables faster data writes and searches and lower storage costs. CSS Elasticsearch offers 6 major performance enhancement features. They are decoupled storage and compute, flow control, large query isolation, enhanced aggregation, read-write splitting, and enhanced data ingestion. Next, we're gonna explain each one of them. Key Enhancement 1. Decoupled storage and compute. In large-scale data systems, there are hot data and cold data. Hot data refers to data that is newly written in. Such data is typically stored on SSDs to enable quick search. As time goes by, data becomes colder and less frequently accessed. Such data is then offloaded to OBS, where there is no need to keep replicas. The cost of storing cold data is significantly reduced. After storage offloading to OBS, a cache policy is designed to maximize query performance by minimizing OBS access requests. When cold data is queried for the first time, it is retrieved directly from OBS. The retrieved data is then cached in the cluster's memory. When such data is queried again later, the cluster will try to find the data in the cache first. This improves cold data query performance without increasing the storage cost. The high O concurrency supported by OBS fully compensates for the latency overhead caused by storage and compute decoupling. Used with an optimized cache policy, this technique can achieve performance comparable to local SATA disks. Key Enhancement 2. Flow control. Flow control applies to individual nodes. You can configure blacklists and whitelists per node, the maximum concurrent HTTP connections allowed, and the maximum HTTP connections allowed. You can also configure node heap memory-based flow control that uses a back pressure mechanism or one-click traffic blocking. CSS can also collect statistics on node access IP addresses and URLs. When back pressure is enabled, large requests will be rejected by nodes when their heap memory usage is high. This mechanism prevents nodes from breaking down and reduces the risk of node unavailability. Key Enhancement 3. Large query isolation. You can isolate query requests that consume a large chunk of memory or take a long time to execute. This way, you ensure service availability for other requests. If the heap memory usage of a node is too high, an interrupt control program will be triggered to terminate one of the large queries based on the policies you configured. This helps to ensure overall query performance for Elasticsearch clusters. Key Enhancement 4. Enhanced aggregation. In the case of data clustering, vectorization is used to process data in batches, enabling faster statistical analysis based on ranking fields. Enhanced aggregation performance enables faster time to insight. Clustering relies on clustering keys, which are part of the ranking keys. Data clustering significantly reduces the cost and the retrieval and computational overhead of inverted indexing. Pruning limits queries to the required buckets only, ensuring search performance in a large-scale cluster. With ranking, highly clustered data is locally ranked temporally, significantly reducing the overhead of aggregating data by time. Key Enhancement 5. Read-write splitting. A real-time synchronization link is established between clusters, supporting either full indexes or limited scope indexes. With the read-write splitting architecture, one write cluster is used along with multiple read clusters. The write cluster handles write requests, while the read clusters handle query requests. The read and write loads are separated, improving the cluster horizontal scalability while reducing latency and jitter. Incremental file synchronization protects queries from frequent log playback. This significantly reduces the average latency and jitter. Furthermore, in case the write cluster fails, a RAID cluster can take over to handle write requests. This ensures service availability. Key Enhancement 6. Enhanced Data Ingestion Performance. Ingestion performance enhancement includes optimized bulk request routing, optimized bulk aggregation, text indexing acceleration, and index merge task optimization. You are advised to use this feature for clusters that contain a large number of index shards and text indexes, or have a high inbound data throughput. With optimized bulk request routing, the data of bulk query requests is automatically rerouted to specific nodes to reduce request distribution and queuing. And a cluster that has a large number of index shards, this can significantly enhance write performance and reduce write request rejections. Documents in a bulk request are written in batches rather than individually. This helps to reduce the overheads of memory requests, lock requests, and other calls, enhancing data ingestion performance. Text indexing acceleration primarily targets log analytics scenarios. With it, the log delimiter is simplified by optimizing the logic for part-of-speech analysis and letter case conversion. This can significantly enhance performance in indexing text fields, including text and keywords. With index merge task optimization, more merge threads are used, and lessons to phase index building is changed to a one-phase process. This helps mitigate the impact of index merge tasks on data ingestion performance. To use these Elasticsearch enhancement features, you need to configure your Elasticsearch clusters on the CSS console. Step 1. Log in to the CSS Management Console. Step 2. Choose Clusters, Elasticsearch. The Elasticsearch cluster list is displayed. Step 3. Select the target cluster and click Access Kibana in the operation column. Step 4. Configure the features you need. For details, see the Cloud Search Service User Guide. After completing these steps, you get an efficient, stable, and cost-effective search and analytics solution. We hope you find this video helpful. You can visit our Help Center to learn more.